Hey, it's Mr. Qualls. What I'm going to do for this video is talk to you about everything that you need to know for review, as a review for the test that you're about to take. Now, the test is going to be over 11.1, 11.2, and 11.3, which is primarily over a transversal intersecting with two parallel lines. I'm going to talk about that real quick. And then what to do for the triangle sum theorems, which means how many angles, how many degrees are there inside a triangle. If you have three angles, what do they need a total? Excuse me. And then the other triangle sum theorem, which is the exterior angle and the two remote angles. Get that for you. And then the last part is the angle similarity theorems, postulate, not theorem, but postulate. So I'm going to start with the idea of what happens if we have, and how the angles are related if we have two parallel lines. We have two parallel lines and a transversal that cuts through those parallel lines. And remember, when this happens, we make, there are four angles that are created at each intersection. So this is 5, 6, and 7, and 8. Now, there are relationships that exist between, but through the angles, right? So one of the things that when this intersection is created, one of the things that happens is it splits up. There's 180 degrees on the top of that line, 180 degrees below it, 180 degrees over here, and then 180 degree measurement over there. So there's 360 total, but if you cut that in half, then there's 180 on each side of either one of those lines. And what that does is create a situation where there's only two types of angles here. One of them is an acute angle, and the other one is obtuse. The acute angle, which is 2 and 3 in this case, those are equal to each other or congruent, because we don't know what their measurements are, but we know that they're the same, so we can call them congruent. So if somebody told me that angle 2 was 85 degrees, I would also know that 3 was 85 degrees as well. I would also know if 2 was 85, then I know that angle 1, which combines with angle 2 to make 180, if this was 85, and I wanted to know how big angle 1 was, then it's 180 minus 85. This marker's kind of funny. 7, and then I borrow, and it's a 5, and then 17 minus 8 is 9. So we have 95. So we now know that this is 95 degrees. Now, if that one's 95 degrees, that means that 4 is also 95 degrees, because vertical angles are congruent to each other. Also, number 3 is congruent to 2 because of vertical angles. Now, the other thing here is we have different pieces of these, we have different combinations of these angles that are the same. And so that's really what we're getting at here. If we know angle 1, which other angles do we also know? Well, if we know angle 1, we also know angle number 5. Because angle 1 and angle 5 are in the same position in each of the intersections. And these are called corresponding angles because they correspond to each other. They're in the same spot in the intersections. And it's kind of like a special communication that they have, right? So 1 and 5 are corresponding, so they're equal. That means that number 5 is also 95 degrees. Number 2 and number 6, angle number 2 and angle number 6 are also corresponding. That means 6 is 85. Okay. Angle 1 and angle 8, are also congruent because they are outside and they are on alternate sides of the transversal as it goes through. So 1 and 8 are alternate exterior angles because they're outside this middle section, which is the inside section. If there's going to be an inside and then outside, that's the only ones that there could be here. So 1 is congruent to 4, it's also congruent to 5, and it's also congruent to 8. Now I could go back here and figure out, well, 4 is congruent to 5. And 4 is congruent to 5 because it's also an obtuse angle, just like 1 is, but 4 and 5 are alternate interior angles. So if they're inside and they're across from each other, they're equal to each other. If they're outside and they're across from each other, they're equal to each other. And if they're in the same spot, they're congruent as well. So when you're going through your test, you need to be able to identify which angles there are relationships with. Now, all of the other videos that I've posted for 11.1, 11.3, and 11.2 are also available to you while you're online taking this test. So if you need one, I guess you could pull it up. I can't, you might as well use the tools that you've got with you, right? Okay, so another thing that you probably need to know is that one of these acute angles and one of the obtuse angles, if you total them together, you should get 180 degrees. In fact, you have to. What that means is that if I took 6, which is acute, and 4, and put those together, it's 180 degrees. So if I know one of them, I know all of the other angles here. That's why 4 and 6 are referred to as same side interior angles, because they're on the same side and they're both inside and they equal 180. They total to 180. All right. All right. That's about all you need to know about this idea right here for the test. The basic idea is you need to know what the relationships are, right? Wow, that blue marker does not want to come off of there. Oh well. Just keep going. I'll change markers. How about that? Okay, next thing you need to know is there are 180 degrees inside a triangle. So what are you going to do about that? What are you going to do when you have a triangle that has 180 degrees inside it and you don't know what the angle is equal to? Well, or total. Well, if you had 70 and this one was 80 and you needed to figure out what that angle over there was, all you'd have to do is figure out that 80 plus 70 plus x equals 180. Put these two together and then take it away from that, and that's whatever x has to be. So this is 150 plus x equals 150. I'm going to subtract 150 from each side. Whoops, that was still 180 over there. And, oh, it's 30 degrees. Does that make sense? Well, if I put this 30 here, 30 plus 70 is 100, plus 80 is 180. Sounds good. All right. But what if something really crazy happens, like we don't get numbers in here. Instead, what we get is a bunch of variables and things like that. So what if we got x plus 5 down here, and 2x, and then let's go 3x plus 10, and then let's put let's go negative 15 over here. Okay. Well, what are we going to do with those 3? How do we figure this out? Well, what do we know about 3 angles like this inside a triangle? Well, we know that if we put the 3 of them together, we have to get 180. So x plus 5 plus 2x minus 15 plus 3x plus 10 equals 180. put the x's together, put the numbers together. X, here we go, 6 x's, and 10 plus 5 is 15, minus 15 is 0. So that's actually 6x plus 0 equals 180. Divide both sides by 6. 180 divided by 6 is 30. 30 plus 5 is 35. 30 times 2, which is 60, minus 15 is 45. 30 times 3, which is 90, plus 10 is 100. And there we go. All right. So again, pretty easy stuff. Just need to know that things total to 180, right? Now, here's our third idea, or our second idea with the triangle sum theorem. Now, if we don't have this third angle, we have studied the idea that this angle here, this angle plus this angle, is the same as this angle outside over here. So a lot of people ask me, what are remote interior angles? Well, they're remote interior. So they're inside interior, they're inside the triangle. They're remote, so they're away from. Remote means away from. So these two angles are remote interior to this angle right here, because this one is outside the triangle. So these two equal this out here. Now, what does that mean to us? Well, that means that if we're going to solve, and let's say we knew that this angle out here was 200 degrees. Whoa, that's too much. Sorry, I was thinking of something else. What if this angle out here was, let's say, 120 degrees? All right, 120 degrees. And we knew that this over here was 2x, and this angle was 1x, or let's say 3x minus 10. All right, that means that if we took this angle and that angle and we added them together, they must equal the 120. Now everybody's like, well, I thought you said they equal 180. They don't. The three inside equal 180. If you don't have the third one inside, you can't use 180 because that's not what these equal anymore. These two equal the one on the outside. So kind of it's the only one that they give you, and you just equal it to those other two. So this is 2x plus 3x minus 10. 2x plus 3x minus 10 equals 120. And then we're going to add 10 to each side here because we want this to be a 0. And in order to make it a 0, since it's being subtracted, we add it. That makes this 130 over here. 2x plus 3x is 5x. Divide both sides by 5. This is x equals 26. The way I got that so quickly is I know how many nickels there are in a dollar. There's 20 nickels in a dollar, and then there's 6 nickels and 30 cents. 20 plus 6 is 26. It's not magic. It's just the distributive property. All right. So x equals 26. So now what am I going to do? I'm not done because that is 2 times x. So 2 times 26 is 52. And then this is 3 times 26, which would be 78 minus 10, which would be 68. Then if you wanted to find this one, you could take 180, subtract 120. That has to be 60. And there we go. Okay. The last thing you need to know for the test is if you have two triangles, and you want to know if they're congruent to each other. And this one is, let's say it's 58 degrees over here, and this one is 40 degrees up here. And then you know that this one's 40 degrees, and This one over here is, oh, let's make it 72. And we want to know, are these congruent to each other? Well, we need to figure out what that third angle might be over there, because what the third angle might be. So what we should do is we need to figure out what this angle is, and if this angle matches that one, they're the same, because then they'll share at least two. But right now they only share one angle. So what we're going to do is we're going to take 58 plus 40, which is 98, and we're going to subtract that from 180. 180 minus 98. Draw that a little better. 7. This is, why in the world did I borrow? I borrow because I watch you guys borrow all the time. So this is 180 minus 90. Looks like 90 degrees. Okay. So that means that this is a 90 degree. That can't be right. It wasn't 90. What happened was, oh, I know what I did. So 40 plus 58 is 98. All right. We're going to subtract 180. We're going to subtract 98 from 180. So that's why I borrowed. 7. Sorry, my head's a little foggy. I'm not completely well. How about that? Still got a little thing going on here. So 10 minus 8 is 2. And then 17 minus that is 82. So this is 82 degrees. Now, it does not match that angle. So this is 40, 40, and then 72. That means this is going to be 68 over here. So they do not match. Okay. If this over here had been 50 degrees, if that had been 50 degrees, and when I took 108 away, and I got 72, and this was 72 degrees now, they still don't match. It's not going to work. It's not going to work. All right. All three of them need to match in order, or two of them need to match so that the third one falls into place as well. Okay. So there we go. So what you need to do the problems on the test. If you need to come back and watch this for any clarifications or any other videos that we've already gone over that are in 11-11.1, 11.2, or 11.3, go ahead and go back and watch those and answer the questions on the test. Okay. I'm anticipating that everybody's going to do very well on this. All right. Yeah. Thanks for watching.